The data set below shows the responses given by a sample of students that were asked the question, how many tacos did you eat last week? Calculate the standard deviation of this data set. All right, so first thing to notice, this is a very, very small data set. In practice, no one's really doing any statistical analysis on 10 numbers. It's usually hundreds of thousands of numbers. But for the sake of this example, since we're going to do it out by hand, we have a small example. Now, we have a formula, which I covered in my notes. The formula for the standard deviation, which is given by lowercase s, is, well, we have to take the sum of the squared deviations from the mean. So that's x minus x bar squared, and then we add them up. Then we divide this by n minus 1, that gives us the variance. And then we take the square root of this expression, and that gives us the standard deviation. So, first thing we notice when we try to apply this formula, we can't calculate the standard deviation without first calculating the mean. We need x bar. So we need the mean of this data set, which means we have to add up these 10 numbers. So to find the mean, to find the average, we add them up and divide by 10. Okay, so take out our trusty calculator. 12 plus 3 plus 0 plus 5, 6, 5, 1, 2, 8, and 6. Okay, so we add them up, we get 48. So the mean is 48 divided by 10, or 4.8. Okay, so the x bar in this formula is 4.8, and the n, the number of values, n is equal to 10. All right. The x values, that's our data. So we have 10 individually different x values. So what this formula is telling us to do is, let's make a little chart here. So for each x value, we have to take x minus the mean. And then once we have that number, we have to square it. X minus the mean squared. All right, so first number is 12. 12 minus 4.8 is 7.2. Next number, 3. 3 minus 4.8. That will be a negative 1.8. And you can do this on the calculator if you like. The next x value of 0. 0 minus 4.8 should be minus 4.8. Then we've got a 5. 5 minus 4.8 is 0.2. 6. 6 minus 4.8 is 1.2. Another 5. So that'll be 0.2. 1 minus 4.8, negative 3.8. Let's see, 1, 2, 3, 4, 5, 6, 7. Then there's a 2, an 8, and a 6. Okay, whew. 2 minus 4.8 is a negative 2.8. 8 minus 4.8 is a 3.2. 6 minus 4.8 is 1.2. Okay. Let's bring the calculator back. Now, our formula is telling us to take each x value and subtract the average, subtract the mean. That's what we did first. So order of operations, parentheses first, then exponents, then addition on the outside. So we need 7.2 squared. So that is 51.84. Negative 1.8 squared. Oh, I didn't put the parentheses. All right, well, that's going to be positive 3.24. Anytime we square a number, it's going to be positive, so we don't need to put in the negative sign. 4.8 squared. That's 23.04. 0.2 squared will be 0.04. 1.2 squared will be 1.44. This is another 0.04. Let's see, 3.8 squared. 14.44. 2.8 squared will be 7.84. All right, almost there. 3.2 squared. $10.24 and 1.2 squared again is 1.44. Okay, so far we've done the x minus the mean. Then we took x minus the mean and we squared each one of these. Now we have to add up each of these x minus the mean squared. So these 10 numbers on the right that we just calculated, now we have to add them up. That's what that symbol is telling us to do. That's the uppercase Greek sigma. Okay, so let's just do it this way. 51.84, 3.24, 23.04, 0.04 plus 1.44 plus 0.04 again plus 14.44 plus, oh, forgot a 4 there, 14.44 plus 7.84 10.24 and 1.44. All right, so we have added these up and we have 113.6. All right, so the first thing we did was the subtraction. Second thing we did was the squaring. Third thing we did was the adding. Okay, and now the fourth thing we have to do is take that sum that we just calculated, that's the 113.6, and we should divide this by 9. N minus 1, in this case, n is 10. There's 10 x values or 10 data values in the problem. So we'll divide by 10, or let's just call it n minus 1. So when we actually do the division, we will divide this by 9. Okay, we're almost there. Divided by, okay, 12.62222 and so on, 2 repeating. And the last step in our calculation, we are so close. We take the sum of x minus x bar squared divided by n minus 1. So that's the 12.62 repeating. That's where we're at right now. And the last thing to do in this formula is take the square root. So, second square root, second answer. Okay, we'll take the square root of the answer. And we have our standard deviation. Now the rounding rule says use one more decimal place than your original data. Our original data was whole numbers. So we'll round our standard deviation to one decimal place. Okay, so this is actually the variance here. So S is equal to the square root of 12.6 with the 2 repeating, or 3.6. Okay. Now, we've calculated the standard deviation. Right now, we're at 11 minutes and 38 seconds into the video. The standard deviation, it's not even the most complicated formula we're going to come across in this class, but it's one of them. One of the more complicated formulas, meaning there's just a lot of steps. Now, each step is a basic operation. There's nothing to it. It's just adding, subtracting, multiplying, square roots. It's just basic operations, but it's in a complex structure. There's so many steps. It's very easy to make one small mistake. And you won't even know you made a mistake until someone marks your question wrong. So what I would like to do is do this problem again. I want to do it a second time. And as I've mentioned before, I do not want you using the calculator. This is a non-calculator math course. There's no place for calculators in statistics. So what I'm going to do is bring this back over here. All right, so there's our work. I am going to bring Excel into the mix. And I just want to show you how quick and easy it is to calculate standard deviations on Excel. Now remember, it took us about 12 minutes to do this problem. I'll do it in less than 12, excuse me. I will do it in less than 12 seconds on Excel. Equal stdev dot s parenthesis data, close parenthesis, done. And there it is. Problem's done. And that's it. So, and we could actually round our answer. We could even let Excel do the rounding for us. And these two icons right here, if we want less decimal places, Excel gives us the same 3.6. And like I said, less than 10 seconds. So what did I just do? Let's come back here. So on Excel, so remember, I mentioned this course, we're going to be using Excel for a lot of different functions and a lot of different functionality. And almost everything we do in Excel will have the form equal sign. Then the name of the function, and then in parentheses the location of the data. The location of the data. So in this particular problem, it was equal sign. The standard deviation function is STDEV for standard deviation. Now, there's two different standard deviation functions, .p and STDEV.s. Now, the reason there are two different standard deviation formulas in Excel is because there's two different standard deviation formulas in your textbook. we have the sample standard deviation, which we just used. S equals the square root of the sum x minus the mean divided, or squared, divided by n minus 1. And then we have the population standard deviation, which is almost the same, but not exactly the same. Sum x minus the population mean squared divided by the size of the population. So there's no minus 1 in the formula for population standard deviation. So we'll have, for this particular problem, if we use the top formula, we would divide by 10 if that was the population. But since it's just a sample, we divide by n minus 1, which is 9. Slight difference between the two formulas. So we're not going to use this one, because in the original problem, this is a sample of 10 students, sample of 10 people, whatever it was. So equal sign, the name of the function, and this is one you want to write this down. You're going to be using this one a lot as you go through the course. And then the location of our data was A1 up through A10. Let me just bring this back so we have it. So our data was here in column A. So the location of the data is column A from row 1 up to row 10. So there's our location of the data. Let's bring that back. Trying to fit everything on the screen. Okay, there we go. There we go. Okay, so the equal sign, name of the function, location of the data. So we have equal sign, the stdev.s, that's the standard deviation of a sample. And then in parentheses, the location of the data. And that's position A1 through A10. So the purpose of this video, I know now in retrospect it was kind of annoying to sit through it all, but the purpose of this video was for me to convince you that Excel is a much more efficient way of doing statistics than using a calculator. Now, think about learning statistics using a calculator. In this problem, you could use a calculator or Excel. So the calculator just took a little bit longer. But what if this problem was 10,000 numbers instead of 10 numbers? Well, if it was 10,000 numbers, well, now it's going to take us hours to do if we're using a calculator. But on Excel, if it's 10,000 numbers, it takes us the same amount of time. All we would do is change that A10 to an A10,000. If there was 10,000 numbers in column A, it doesn't make it take any longer. So the size of your data set, if we're using Excel, the size of your data set doesn't affect how long the calculations take. The standard deviation of 10 numbers takes the same amount of time as the standard deviation of 10,000 numbers if we're using Excel. Okay, so that about does it for this video.